Sodium aluminate is used in several applications. One of these would be industrial, the other would be pharmaceutical. Today we're going to be making sodium aluminate from sodium hydroxide, aluminum foil, and water. As you can see up front, I am displaying it. So the reasoning we're making this is not because I have any practical use for it, but just wanted to try and make sodium aluminate while I'm waiting for the rest of my lab equipment to show up so I can make more complex things than just sodium aluminate. So we begin by ripping up our aluminum foil from the aluminum, the aluminum roll, because it needs to become a lot smaller pieces, and this allows the reaction to happen quicker between sodium hydroxide and aluminum, since aluminum has more surface area. If I finally grounded this, the reaction might have been a little too untamed, so I decided to keep in at least some larger chunks, some larger pieces, as you can see here. So I'm just ripping it apart, cutting it with a box cutter, which might not seem exactly of highest practicality, but we are just ripping apart the aluminum. So now that we have our aluminum, we are just going to get out a round bottom boiling flask, or a flat bottom, 1,000 milliliters. And the reasoning for it to be flat is so we can easily put it on a heating apparatus, just a hot plate, so it can be flat. And the reason why we're using a boiling flask, of course, is so we can fully dissolute the sodium aluminate and get a better amount together and not have it be in such large chunks. This will kind of cost us some of the yield, which is okay because I don't plan on actually using this for anything, just having it. But yeah, we started adding our aluminum foil to the boiling flask, getting it ready for the reaction of aluminum and sodium hydroxide, NaOH, and of course aluminum being a base element is just Al. And also we're going to use water, just regular water, to dissolute our sodium hydroxide. This may not be the purest method, but I didn't want to waste any distilled water that I used in a distillation apparatus on this reaction, considering I didn't need a really high yield. So in this portion of the video, I actually made a big mistake that chemists shouldn't make, and I will shun myself for the rest of my life for it. I decided to add water to an acid or a base. In this case, it's a base, which is definitely not something you want to do because it causes it to boil and release fumes that can be harmful. And yes, I breathed some of it in. It did not smell pleasant. It actually hurt a tiny bit, just burnt a little bit. But I waited it out. I let the fumes settle, and then I got back to work and added the rest of the water in the ends to fully dissolute our sodium hydroxide. And you'll see in a little bit I use a specific method as well to dissolute it quicker. But at this point, yeah, I'm just sitting in the back, just wondering whether I should add more or wait it out. So I took it safe and waited a little longer. But I eventually added the rest in at the moment that I thought it was best, that the water will have cooled down enough so there was no high exothermic reaction causing bubbling, because I would not like sodium hydroxide on my desk or on anything, because hot sodium hydroxide is probably going to eat it and do damage to furniture. So this clip does manage to be decently long, but anyways, so the rest of the video is just about adding a conical, an addition conical to the boiling flask and adding our sodium hydroxide to it. And in the end, we boil off our sodium hydroxide and water mixture to dissolute the NaAlO2 completely. So yeah, I'm gonna get back to you guys once this is done. So after that extremely long clip, I finally got the rest of the water in, and I decided to heat up the Griffin beaker to fully dilute the solution quicker. So at this point, it's just heating up the flask further to fully dilute everything, as I prepared an apparatus for this specific experiment. So I'll see you guys again in a few minutes or seconds. So at this point, I just readied an apparatus for this reaction. As you can see, I'm placing down a metal plate for the bar to be put in, spun it in, and I was able to strap a addition conical to this apparatus, and below I had placed the boiling flask, as you'll see soon, and we slowly drip fed the sodium hydroxide to the aluminum to yield sodium aluminate. the reasoning why we're using addition conical instead of just straight up pouring it in is because I've had issues in the past where if you just straight up pour it in, it reacts violently and starts boiling over and spraying sodium hydroxide everywhere. So I wanted to perfect it this time and make sure that the reaction was going correctly. So right when I put on the apparatus, I actually allowed some of it to drip into the boiling flask to start the reaction while I was finishing up the rest of the apparatus. But basically what is happening in the reaction is that sodium hydroxide, which is NaOH, is reacting with aluminum to yield NaAlO2, which means it's one sodium, which is an alkali metal, and an aluminum atom, and 2 oxygen atoms. There are many different chemical formulas for sodium aluminate, but that is the most common one that I just said at the moment. So what is happening in this reaction is that you can see that in a minute, you'll see that there's actually a gas that is being released in the boiling flask. And you're probably wondering what exactly that gas is. Well, that gas is actually hydrogen, H2. The reason why it's H2 is because usually when the hydrogen gets bumped off of the sodium hydroxide, the NaOH, it usually bonds with itself, and sometimes just one hydrogen stays by itself and the rest becomes H2. This is, of course, really dangerous to breathe, which is the reason why you see that little ventilation to the left. That's basically my fume hood at the moment until I get my lab set up. But yeah, I dispersed the hydrogen gas as it was exiting. But you can begin to imagine why I was slowly drip feeding it into the boiling flask, because you can see of how much hydrogen gas is being released by just little droplets. It's a massive amount of hydrogen. If I were to release the entire conical or just pour it in via Griffin beaker, it would probably start boiling and fill up the entire flask and pour over and then screw up everything, because of course sodium hydroxide has a pH of 13 to 14 on the pH scale, which is pretty much the max. That's why when you see a pH scale, it uses pH of 13 to 14 of relevance to drain cleaner, specifically sodium hydroxide drain cleaner, as I do know that there is other drain cleaners that use sulfuric acid, which would be a complete opposite on the pH scale. But anyways, so as you can see, it's yielding little black pieces of aluminum at the bottom. The aluminum's changing. That change is going from Al aluminum to NaAlO2. So the sodium is bonding with the aluminum, and the 2 oxygen molecules from 2 different molecules of sodium hydroxide are bonding to 1 molecule of sodium aluminate. So therefore, in the reaction, there is also some excess sodium and sometimes oxygen as well. But usually not enough to even really think about or actually associate with the reaction. So as I noticed that the reaction was becoming more and more tame, I started to open up the addition flask more and more, allowing more and more in, and then I knew that the reaction was completely done once there was no boiling and there was no production of hydrogen gas. I actually wafted a few times and there was no hydrogen gas left, so I just let the flask fill up all the way to make sure that all of the aluminum had reacted and there was no aluminum left, at least on its own. So yeah, this clip is, again, pretty long because I wanted you guys to be able to see the reaction in its entirety. I of course, quicken these. As you can see here, I take a pH strip and I show that the pH is actually near 13 to 14. So I didn't bring a scale over to show you exactly what purple meant, but trust me, it means 13 to 14. So I wanted to make sure there was no discrepancies in this reaction, so I added just enough, about 400 milliliters of sodium hydroxide solution, to make sure that it filled up at least almost halfway of the boiling flask, so I knew that all of the aluminum was in contact with sodium hydroxide, and I didn't have to move around the flask or swish it around. So yeah, I'm gonna let you guys watch the rest of this reaction, and I'll see you guys in a few minutes. So at this point, all of it had reacted, and all we had was sodium hydroxide solution left over and sodium aluminate. So I wanted to make sure, because it was looking very cloudy, so I wanted to make sure that all the sodium aluminate was completely dissoluted, so I could give it an ice bath and it would just settle at the bottom. This, of course, does sacrifice some yield, but it gets into a bigger clump, as you can see. When you'll see later on in the video, this gets into a bigger clump of sodium aluminate, and it's easier for extraction and filtration of the yield. So this is just basically me boiling it. If you guys want to see, or you can skip to the next portion of the video, which is the final yield ice bath and extraction into a smaller flask. So see you guys in another few minutes. So I finally was done boiling it off, and now I was going to give it an ice bath and let it settle. So I get out a small little glass sort of pan or a bowl, and I fill it up with ice, and I take my Griffin beaker that is holding the sodium aluminate, and I basically put it into the ice bath. This allows it to settle easier. Of course, what you're looking at right now, the footage, I wasn't anticipating giving an ice bath, but then I thought about it and thought maybe it would be a better idea to do that, to let it settle easier. And then after this, I waited a few days and I waited just basically a few days, maybe 2, maybe 3, I can't remember exactly, but I then took it out and transferred it. As you can see here, I'm going to transfer it to an Erlen. I'm going to transfer the sodium hydroxide that's left over with the the aluminum, the sodium aluminate, and try and filter it, kind of like a coffee style method. And it's so far worked, but the boiling method that I used works so well that this wasn't even really necessary. The sodium aluminate was stuck together so well, but then it broke apart because I was kind of being an idiot swishing it around. And of course, really, really tiny particles of sodium aluminate were lost in this process, but once again, we're not talking about yield. If you guys want to get a larger yield of this and you have an actual practical use for this, don't do this the method that I'm doing it. You're probably going to have to go through a process of distillation and a few other methods. So I started pouring into a small flask. Sorry about the camera movement, because I didn't mean for it to swish around that much, but I really wasn't up for pouring sodium hydroxide on myself nor my desk. So once I have my lab, I can actually start doing this a little more safely and in a manner which I like. So there's our sodium aluminate. So probably just distill it and get a better yield, but that's pretty much it. There's our sodium aluminate. The